Hi friends, welcome back to the channel Java Coding Interview Preparation and Coding Insight. Today we are going to solve AtCoder Beginner Context 96 problems 5 everywhere. Before we start looking into the problem details, some examples and the solution in Java for this problem, I want to mention that my channel is dedicated to help people in their Java and coding interviews. On my channel you will find lots of helpful videos if you are preparing for Java or coding interviews. There are over 350 solved different varieties of coding problems which are taken from previously asked coding interview questions by big tech companies like Apple, Amazon, Google, Facebook, Microsoft, Yahoo, and many other big financial clients. So if you are preparing for any Java interviews, telephonic Java interviews, in-person interviews or coding interviews, then this channel can definitely help you in your interview preparation. So please subscribe to the channel now. So let's go through the 5 everywhere problem statement first, then we'll discuss how we can solve this problem. So print sequence A1 to AN whose length is n that satisfies the following conditions. So AI is between 1 and I is between 1 to n inclusive is a prime number at most 55555, right? This is the maximum prime number it is. The values of A1, A2 to AN are all different. So this is a series of numbers and basically prime numbers, right? A1, A2 to AN, and they should be different basically. In every choice of 5 different integers from A1 to AN, the sum of those integers is a composite number. So we can give the series of A1 to AN and we can choose any 5 different integers from that series, and it should the sum of those 5 integers should create a composite number. That is what the question statement says. Uh, so they have here in the note section they are telling us what is a primary number and what is a composite number, right? So let's just go here. N is not less than 2 is called prime number if it cannot be divided evenly by any integers except 1 and n, means 1 and itself basically, right? So for example 5, right? So 5 can be divided only by 1 and n, right? It cannot be divided by anything else. But other number like is called as composite number. So what is a composite number? For example 6, right? We can create 2 into 3 is equal to 6, right? So we can divide them into two different numbers, right? So that is called as a composite number. The constant is n. The number n can be between 5 and 55 inclusive. So output, they are saying that they will give us the n, for example 5 here they have given, and we have to print A1 to AN, means 5 different prime numbers we have to print with space in between, and the constant they already told us, right? Here they have given us 5, but they can give us any number between 5 to 55, right? For example here they gave 6, after that they gave us 8. So we have to print those many prime numbers, and the constraint is that we can choose any 5 numbers from that given numbers, right? 5 different numbers, and it should sum up to a composite number, right? So let's just take a look at this example that they gave us here. So the first example is this, right? So they are asking us to provide 5 different prime numbers sequence like this, right? So they have given us one output example here, 3 5 7 11 31, right? This is one example. So if you sum up all these 5 numbers, now we can take, they said that they will give us any number between 5 and 55, and we have to print the series of that many numbers, but in this case they just gave us 5, right? So we have to choose all the 5 basically. So if we choose all the 5 and then if we sum them up, right? So if we sum it, let's sum this thing. So 31 plus 11 is 42, so plus 7 is 49, plus 5 is 54, and 3 is 57. So 57 is a composite number, right? So here they are showing us 57 is a composite number, right? 19 into 3, so we can do a composite number 57. So that is what the requirement is basically, right? So they are saying that we can give another possible output also, like this is also one other sequence we can give. So we can choose any number from this sequence, any 5 numbers, and if you sum them up, they will create a composite number. So they have shown us some other sequence here. So this is what the problem is basically, right? So they can give us large number also. Here they have shown us example of 8, but they can give us like maybe 10, 15, anything between 5 and 55, right? So we have to print that many numbers. And we have to be able to choose any 5 numbers from that, and they should create a composite number. So that is what the problem statement is. So let's understand how we can solve this problem, right? So I hope that you already know what a prime number is. So they already told us. So prime number is a number which can be divided by 1 and itself, right? So this is, for example, this is the series of prime numbers, right? So 11, 31, 41, 61, for example, these are all prime numbers basically, right? So any number you take, let's say if you take 31, 31 cannot have any components, right? So this is a prime number basically. So it is divided by only 1 and 31, right? 1 and 31. But if you take 32, so 32 is a composite number, right? Because it can be created using 2 and 16. One example is, right? For example, 2 and 16 we can use and create the 32. So this is how we can actually create the composite number. So here first we will actually go through like we will create this series first using a for loop which will go from 2 to certain range we will go, right? Let's just assume for the simple conversation that we are creating it from 2 to 100, right? So what we will do is we will, let's say this is our I, so I will go from 2 to 100 and we will create this series from that numbers, right? So first we are going to create this series. So how we can create the series is because we will use this something like this formula, right? So we'll do I into 5 plus 1, right? So I can be 2, for example. So 2 into 5 is 10 plus 1 is 11, right? And always before we add into this set, we will make sure that that is a prime number, right? So we will implement one small helper function that will check if this number that we are generating is a static like a prime number or not. So here we are using I is equal to 2, for example. So it will give us 11. So we will add it to this series, right? It's a prime number. So we'll add it to this series, right? After that our I will be 3, right? So 3 into 5 is 15 plus 1 is 16. So 16 is not a prime number, right? So we will not add it. Then we will keep going. So after that we will reach 6, right? So 6 into 5 is 30 plus 1 is 31. So this is also a prime number, 31. So we will add it into this series. So similarly we will keep going and until certain extent, and we will first prepare this list. So this one is a kind of a list of all the prime numbers, right? Where we created these numbers by using a factor 5, right? So we use this factor 5 here. So I into 5 we are doing, right? Plus 1. So we are using a factor 5 because we want to take any series of any 5 numbers from these numbers, right? So that they can create a composite number. That's why one of the reason why we are using 5 here, right? So once you generate this series, now you will see that any 5 numbers we take here, any 5 numbers for example, right, they will always give us a composite number. So let us try just by seeing these first 5 numbers, right? So first 5 numbers if you take, they will give us a composite number. So actually let's do one thing. I created, like, I'm just taking the first 8 numbers here, right? So I will go until this point. So 101, 131, 151 also we will include. So if we create the sum of all, I just took this sum, right? This is the sum of all these 8 numbers. So if you look at these 8 numbers, it is giving us 598, right? So 598 is a composite number. It is not a prime number, right? Because it can be divided by 2. So if you remove any, if you do any combination, for example, if you, let's say, remove if you take any 5 numbers now, for example, if these are the total 8 numbers, right? 1 2 3 4 5 6 7 8. So we will just remove this first 3 numbers, right? So we'll just again take a sum of these numbers. So once you take the sum, it is 515, which is dividable, like which can be divided by 5, right? So it is a composite number basically, correct? So any numbers if you take from these sequences, it will always give, any 5 numbers will give you the composite number. So let's again try to do some other uh, uh, like let's say these two we will remove and this we will remove. Any combination you take, you always get a composite number. So again we will see here. So 425 again is a composite number because you can divide it in between like 5 and other component, right? So it is a composite number. So that is how our approach will work to solve this problem 5 everywhere. So just before we start implementing and going to the Java code, we'll just take some other random numbers just to make sure that it works correctly. So these 5 numbers we will take, and let's say 331 we are taking, right? So let me just take these numbers to make sure that it's working fine. 181, 241. So we can just write here actually 181 plus 231, right? 241, 271 plus 311 and 331, right? 311 and 331, right? 331. So if you sum them up, it is giving us a factor. Now you can factor it with 5, right? Any random numbers you can choose. With these numbers, always it is a composite number, right? Because we use this factor 5 here, and that is one of the main constraint here. As you can see, that's given in the problem itself, that every choice of 5 different integers, the sum of those integers is a composite number, right? So that's how we are getting composite number. Let's say instead of this 331 we choose, let's say 491, right? So let's just make sure that also works. 491, let's choose it. So again it is giving us a factor of 5, right? So it is a composite number, it's not a prime number. So this is the way the solution works. So let's just go to the Java code now. So first thing is, I'll just show you the prime number function here. So we are passing just a number, like this is just a static prime number function where we are passing a number, and we will go from 2 till the middle of the number, right? We will just divide that number by 2, and we are going to check if that is a completely divisible by that number, right? If it is completely divisible by a number like a 2, 3, 4, 5, we will go until the middle of the number. Then we will just set the flag to true and we'll just break it out, right? So in that case we will just return either true or false. So we will know that it's a prime number or not a prime number, right? So that is what we are going to do first, and after that we are going to implement our function here. So we will take n here. So n is given to us in the input, right? So n is given to us in the input here. So 5 is given to us. So after that we are going to define one set which is a hash set of integers, and we are going to go from I is equal to 1 till I is equal to, this can be big number, so we can just put here 1 1 1 1 0, right? So it will give us a large number of prime numbers into the set, right? So we will keep generating using I into 5 plus 1, right? So this one as we discussed here, so we will use that and we will keep generating these numbers, right? And then whenever we find that number is a prime number, we will keep adding that number into the set. So here we are adding the number into the set, and after that we are just going to take the set and we are going to create a list of integers here, and after that we are just going to, so array list in Java has a constructor where you can just pass a set and it will create a list out of the set, right? So we are using that. So here it is going to create a list of integers here, and we are going to use collection sort method to sort the list, right? So as you can see, this one is a sorted, right? So this one is in sorted order. So 11, 31, 41, 61. So this is a sorted order in ascending order, right? So this is what we are creating here first by collection sort, and after that we are going to just go from 0 to n, right? Because whatever numbers we want, like for example, if n is equal to 8, right? So if n is equal to 8 is given to us, we will take the 8 numbers from the starting here, and we will just create the output basically, right? So for example, we will have 11, 31, 41, 61, 71, 101, 131 and 151. So these are the 8 numbers, right? If it is 5, then we will just choose the first 5 numbers. So whatever n they have asked us, we will just choose that many numbers, and we will just put it into our string builder, right? We will keep appending into string builder. We will put a space here, and we will be in the loop, and at the end we will just print the string builder, right? So let's just go ahead and execute this code snippet and make sure it works for n is equal to 5 first, and then we will go through other n numbers. So let me just execute this. So as you can see, it is working for n is equal to 5. It has generated these 5 numbers: 11, 31, 41, 61 and 71, right? So 11, 31, 41, 61 and 71. So if you calculate this sum of these 5 numbers, right, then it is giving us a composite number, correct? So I'll just make sure that I'll show you that. So 11, 31, 41, right, 61 to 71. So these are the first 5 numbers it generated. So let's just make sure that it is creating. So 215, which is a composite number, so it's giving us a correct answer. So if we can change it, like let's just go ahead and change it to 8 now, and make sure it gives us the 8 numbers, like the prime number sequence. So this is the 8 number prime number sequence. So this sequence also is the same sequence that I showed you just now here, right? So it will give us all these numbers, right? 101, 131 until 151. So let me just add them up together, and we'll just make sure that the actually we can randomly choose any 5 numbers between these 8 numbers, and it should create a composite number for us, right? So let me just randomly I'm choosing some numbers here, 5 numbers. So it has generated a composite number 405 because it is divisible by 5, right? So it will be a composite number and not a prime number. So this is how the solution works here for this problem. So I hope that I explained you using this series, and you got the idea of how we can solve this problem with the help of we first generated the series of prime numbers, and after that we are taking the n prime numbers from this series, right? So you can choose any prime numbers, and it will give us the any 5 numbers we can choose, and it will give us the composite number, right? Because 5 we used it in the formula because we want to make that factor of 5, right? Because they wanted actually the 5 numbers here, right? Every choice of 5 different integers should sum up in a composite number. That's why we are choosing 5 there. So if you are new to my channel, there is a dedicated AtCoder playlist that you can watch for, like there are a couple of examples solved and explained using whiteboarding sessions. Also there are other important coding playlist. The names of the playlist are Leetcode and Leetcode solutions, as well as Code Forces and Code Chef. So all these playlists have over 400 different varieties of coding problems that are explained using whiteboarding session examples and Java code. So you can go through them. It will give you wide range of varieties of problems that are very important from coding interview perspective, such as BFS, DFS, graph problems, binary search tree problems, problems related to linked list strings, optimization problems using priority queues, dynamic programming problems, as well as lots of logical questions that are previously asked by big tech companies like Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big financial clients. So if you go through those playlists, it will give you a really good idea about what questions are generally asked in coding rounds, and you will get to see vast varieties, so will give you a good preparation. Also, if you like this video, if you find this video helpful, and if you like the way it's created with whiteboarding session examples and Java code, then please give it a like. Also put your comments comments in the comment section and tell how you like this video, and also share this video with your friends and colleagues who might get benefited by watching this video if they are preparing for coding interviews or Java interviews. And I'm going to give you the link that we have discussed the this code actually, right? So you will get this code link into the GitHub account that I'll share you the link in my description. There are lots of other Java solutions available on my GitHub account. If you like these solutions also, then if you want to appreciate it, you can give a star on my GitHub account also to the GitHub projects. So that might be helpful. And thanks for watching this video.